In the last video, which was quite long, we looked at dividing polynomials, specifically long division. That is a difficult process, and I hope you spend enough time practicing it. In this lecture, we want to start talking about factoring polynomials, which is probably one of the most important things we talk about in this semester. You're going to use factoring in Math 99, Math 103, and even in your university classes like calculus. So you want to be very good at factoring before you leave Math 99. We're going to start with a review of the greatest common factor. So you remember that we suggested that you could prime factor your numbers. 8 times 3, 4 times 9. And for the greatest common factor, we said that you should use the common factors to their to their lowest exponent. So we see that both 24 and 36 contain factors of 2, at least 2 of them. Both contain factors of 3, at least 1 of them. The greatest common factor of 24 and 36 is 12. Pause your video and find the greatest common factor of 45 and 54. We see that both 45 and 54 contain the prime factor of 3, at least 2 of them. The greatest common factor of 45 and 54 is 9. When we're looking at variables, we can see for x squared, x to the power of 5, and x to the power of 4, that x squared is our common factor. We're always using the lowest power. They all have at least 2 x's. So when we're asked for the next question to find the greatest common factor of 45y cubed and 54y to the power of 5, well, we already found the greatest common factor of 45 and 54. And we know that the lowest power here is y cubed. So factoring polynomials. When you're asked to factor, you're being asked to write the polynomial as a product. Remember that product is the answer to multiplication. So we're looking at a factor multiplying a factor. That's when you know it's in factored form. There are 5 strategies that we're going to talk about in this course: using the greatest common factor, factoring by grouping. We'll look at quadratic trinomials, a difference of squares, and the sum or difference of cubes. You need to know all of these different strategies. They are all important, and you will be asked to explain how to do all of them on your final exam. We're going to start by looking at using the greatest common factor. The first step is, of course, to find the greatest common factor. We just did a quick review of that. The second step is to divide each term by the greatest common factor. And finally, to write this as a product. Remember, this is a multiplication question. In this case, the greatest common factor multiplying the quotient. So if we look at our first example, here's this polynomial again. We already found the greatest common factor for this. We said it's 9y cubed. The second step is to divide each term by the greatest common factor. And finally, we want to write this as a product of the greatest common factor and the quotient. So we keep the greatest common factor and we multiply by the quotient. We're just dividing monomials here. So we have 5 minus 6y squared. How do we know if this is correct? Well, we can just quickly check by using the distributive property. If I multiply 9y cubed by 5, it gives me 45y cubed. If I multiply 9 by negative 6y squared, it gives me negative 54y to the power of 5. So we can use the distributive property to check if our factoring is correct. Oops, there went my y. So what about question 2? What's the greatest common factor here? I hope you can see it's 15. We're going to divide each term by the greatest common factor. And then our factorization is the greatest common factor times the quotient. And again, if I use the distributive property and multiply it back, I can see it gives me the expression I started with. Pause your video, try question 3. In factored form, the greatest common factor times the quotient. Question 4 looks interesting, perhaps a little bit difficult. Let's rewrite this. What if I let everything in the brackets equal x? Then I would have the question yx plus 3x. Now I can see that the greatest common factor is x. And if I divide by x, I'm left with y plus 3. So we don't have an x there, but we do have a common factor. The common factor is x squared plus 2. When we divide each term by x squared plus 2, what's left? Well, remember our factored form. It's the greatest common factor. It has to be in brackets because it's a binomial. When we divide out the greatest common factor, we're left with y plus 3. Strange to look at, but it shouldn't be too difficult. Pause your video, see if you can factor questions 5 and 6. In question 5, we found the greatest common factor is 6ab. So we keep our greatest common factor and multiply it by the quotient, 2a minus 3b minus 1. In question 6, we found the greatest common factor to be 5x. Keep the greatest common factor, multiply it by the quotient. There's 2 more questions here. Why don't you pause your video and factor these? The greatest common factor for question 7 is 2x plus 3. When I divide out the greatest common factor, we're left with 3x minus 5. There it is in factored form. We can do the same thing in question 8. 4x plus 1 is the greatest common factor. When we factor it out, we're left with x plus 2. And there that one is in factored form. Let me remind you that order does not matter here. We could write this as 3x minus 5 times 2x plus 3. We could write this one as x plus 2 times 4x plus 1. Both are correct.